Okay, good morning everyone. Today we are going to talk about the database services offered by Amazon Web Services. We so far has covered the compute part of it, the networking layer which supports the compute and security aspect of it, and also the storage part of it, that is object, block, and also the file system based of storage. So if you want to have a permanent data store, you will need a database for your applications. That database can be an SQL based database, or it can be a NoSQL based database, or it can be a data warehouse where you want to do perform a big data analysis or some kind of reporting queries and all those things. For that, Amazon gives you quite a variety of offerings for that, and we will cover some of them in today's classes. So, as usual, the agenda is the what and where of RDS and Elasticache and when to use them, the basic common use cases, and I will also cover the building blocks, that is how to set up an RDS and what are the important elements of an RDS. Or saying RDS, I can say what are the important elements of setting up a database and what you need to really know when you're trying to set up a database and how to take a backup and restore from a backup. Those are some of those things that we will see in the RDS classes. So moving forward, this is the important services that Amazon offers in RDS database as a service, and within this group, okay, within this group we will be particularly looking at the service called RDS, that is nothing but a relational database as a service, that is relational database service, that is for SQL based databases. For anybody who didn't know SQL and NoSQL difference, to put it, if you are ever familiar with an Excel sheet where there is the rows and columns, where the first row is, let us say, name, and in the I'm sorry, the first column is name, and then the second column is, say, for example, age, and the third column is, say, for example, what is your location, what is your email address, so on and so forth. So each column has an attribute for a person, and each row will be, like, for example, the first one will be Kumar, and its name and age will be, all these attributes will be added, and each and every row will define an unique individual, and probably you will create a primary key and those kind of sort. So this is how a NoSQL, I'm sorry, this is how an SQL database looks like. When I'm talking about NoSQL, that is Dynamo DB, just for awareness, you need to think of, you can, if somebody wants to upload a lot of photos, say for example, I want to upload 10,000 of photos, and there needs to be a nice way to catalog all these photos and store it in a nice way. So this is where a NoSQL database comes in, and it sits very nicely. I will create a database with a key and value pair. So for example, here the key will be my name, and the values will be all the file names of my photos and the location of those file names of the photos. So each key value will be tagged with my name also. So all the photos will have my name, the attribute of its file name, the attribute of its location. So it can be searched from all the photos and can be retrieved when a user is asking. So there are some kind of use cases where an SQL database doesn't fit very nicely for storing your data. That is when people use NoSQL databases. So Amazon's NoSQL database is called Dynamo DB. That is nothing fancy about it. If anybody heard of the name MongoDB or Cassandra DB, think of Dynamo DB as an equivalent of same databases in cloud. So there is Elasticache. If anybody is familiar with in-memory databases, so before saying what is before going ahead, I'll say a couple of words about what is an in-memory database. If a particular data is being retrieved quite often by the users, what the database engines do is they copy the data to its own memory, so that the querying process or read-write process happens very fast. So your response times to certain queries, for example, in India, there is, let us say there is an India-Pakistan match is happening, and quite a lot of people can search in Google for the latest score. I personally myself do that quite often. Instead of going to a ESPN.com website or some other website, I just go on Google saying India, Pakistan latest score. You will get the score itself as the first result instead of going to a website. So what Google can do here to speed up the action is they will put these kind of results in their memory and cache databases. And probably, if you remember, we had talked about something like CloudFront and edge location. They will push all this data to the point where it is easier for the user to access and the latency decreases. You will get a almost real-time experience of querying the database and getting the results. That is what an in-memory database is. And if we want to take this concept to the cloud, then Amazon calls it Elastic Cache. And Elastic Cache has two engines. Uh, these are all names of the services. RDS is a name of a SQL database service. Dynamo DB is the name of a NoSQL database service, and Elasticache is likewise is an in-memory caching service. So behind this, there will be multiple engines running. When I say engines, the easiest equivalent example is when I say operating system. Under operating system, I will have Windows, I can have Linux, I can have Solaris, AIX, or Ubuntu, anything. Like that, when I say an database engine, beneath that I can run an Oracle engine, or I can run an MySQL engine, or even a Microsoft SQL engine. So there are multiple engines possible when I'm talking about RDS. So let us go ahead and start seeing more closer what this RDS means. So as it says, RDS is a managed relational database service in the cloud. You can set up, operate it, and do whatever you want. You have multiple engines available, and it automates a lot of time consuming administration tasks. What it means exactly in real terms is you don't get access to the physical server, you don't get access to the physical operating system, you don't get access to the database engine also. You don't install Oracle, you don't install MySQL, you don't configure DB parameters, you don't fine tune those. Let us not say fine tune, you don't configure most of those parameters by default. So you don't have to do the upgrade cycles, you don't have to do the daily operating system management jobs, adding disks and all those kind of things. So that is what a managed relational database service means. All some of those common administration tasks are removed, and I will talk about fine tuning a little bit later. So just think of it that basic fine tuning is not required. Amazon has applied the most common best practices to these RDS databases. That would be a right way to describe it. They have taken a best practices, a common best practices, which will be used or which will be helpful for most of the database use cases, and applied it there. And they give you some flexibility in configuring those parameters if you need them. If you don't need them out of the box, an RDS service works, and you can connect to it by installing an MySQL client or MS SQL client, and you can interact with the database. So this is okay. I should have changed the image. Which one looks good, guys? The first one or this one? No answers. Okay. Seriously listening then. Okay. Nobody wants to talk. Let me move forward. So these are some of the features of an RDS database. Are you able to see my screen? Yes, no, quickly.
Yep.
Yes, yes.
Great. I'll just touch upon each of those features one by one quickly. It is simple to use. Amazon at least claims that it is simple to use. I have found it very easy actually, honestly speaking. I am not a database guy, let me put it very clearly. I am like most of you, started as a system admin, and I spent a lot of time with operating systems, and slowly I moved on to become an architect and solutions architect. So I am not a database guy, but I found starting an RDS instance, connecting to it, interacting with it very, very easy. So I believe I can stretch that statement and say most of you will be able to easily start up an RDS instance and work with it without a lot of difficulties. So I agree to that statement, simple to use to considerable extent. Cost effective, yes, you get about 750 hours of free tier RDS service for T2 micro, yeah, T2 micro instance. Remember that RDS also uses one of your EC2 instance cycles only. That is, you choose an instance type of either T2 micro, T2 large, or M3 large, those kind of instance types that we discussed when we were talking about EC2s. So that is how you scale up your RDS instance. If you want more CPU and more memory for your RDS instance, just like as we do in EC2, we stop the database service and start it with a higher CPU and higher memory instance. So your cost for your RDS instance is calculated two ways. One is we talked about the instance type, and the next one is the amount of storage that is getting allocated, and also whether you are using provisioned ABS volumes or unprovisioned ABS volumes. So your cost goes on in this way, in this two grows in these two ways. Security, you have to put an RDS in a VPC. Without putting it in a VPC, you cannot start an RDS as on today. If you have a very old account, or if you are unfortunate and supporting a very old AWS customer or a client, they might have something called an AWS Classic VPC. One second, guys, just hold on. So, as I was saying, security. If you are unfortunate and working for a very old client, they might be using something called a classic VPC, but that is not available anymore. You will have to put an RDS inside a VPC, and as we have seen quite often, we can create a security group and make sure who can access or who cannot access your RDS instances. So you can define security in these two ways. And also there are IAM rules, IAM policies, in fact, not rules, IAM policies on who can access your RDS instances. These are, let us say, these are three ways of securing a database. And there is one more way is parameter groups. You can disable some features of your database that you don't want to use. So that way you can secure your instance even more. So these are some of the security features available for you to secure your database and the data inside it. Predictable performance, as I said, it runs on a T2 instance, runs on EC2 instance. So there is a certain amount of virtual CPU and certain amount of memory allocated, and it also comes with the EBS volumes. So once you choose a provisioned EBS volume, you are guaranteed to get a certain amount of IOPS. If you remember, we saw IOPS when you were talking about EBS classes. If you chose something like 20,000 IOPS, you are guaranteed to get 20,000 input output operations per second when you choose an EBS volume of that size. So that is how Amazon guarantees that your database performs at a predictable level. And scale to demand, this is not a typical auto scaling here. You cannot automatically have your database scaling for CPU and memory. You will need to stop your database service and then start it with a bigger instance, or you can do a snapshotting and restore the snapshot into a bigger instance. So either ways, there will be some kind of manual hand holding to scale your RDS instance as on today. There is no auto scaling type of features available, especially when I'm talking about RDS. The story changes a little bit for Dynamo DB, but let us not focus there. Let us stick with RDS and learn what RDS does and cannot do. Durability, again, the database uses EBS volumes, and EBS in turn resides on S3 storage. You won't have visibility to those kind of details, but you just need to know that since they are EBS volumes and they are going to use the S3 storage on the back end, your data is going to be really durable, and it is going to be, you won't have failures of disks, and you won't be impacted because of those things, which happens sometimes in on-premises. Compatibility with your applications, that is RDS is typically has a lot of hooks, that is typically it uses the engines which is on the right hand side, and you can connect to most of the application. Most of the applications can connect to these databases very natively. Java has a connector for almost any known database available in the market, I would say. And no administrative intervention. Probably I would like to say some amount of administrative intervention is required. Most of the administration is taken care by Amazon itself. So I'm sorry, I was about to draw this here. As you see, I'm getting myself familiar with this controls here. So there is you can automate backups, you can automate upgrades. Yes, I repeat that, you can automate upgrades also, and you can automate backups. You can automate housekeeping or cleaning your database using some scripts that you can run against the database. Either you can use cron, CloudWatch events, or Lambda to do all those things. So the administrative effort comes down significantly when you're using an RDS service. On the right hand side is the most common, most popular database engines available in the market, and the list that you show here is exactly the same list that is supported by Amazon. You have open source MySQL, open source PostgreSQL, and proprietary Microsoft SQL Server, and MariaDB is also supported, and Amazon Aurora. I will speak a few words on Amazon Aurora here. Before proceeding, I would really like to know, guys, who are familiar with the databases a little bit at least, or because I can skip a few extra dialogues if you're already familiar with the databases. Yes, I am. No, I am. Something like that on the chat window, or speak up quickly. Okay, great. I got 3 responses. Who else do we have here on the conference today? Mr. Strujan and Mahendra, I mean, should I think that whoever is not typed there are familiar with databases? Come on, guys, in the interest of time, pull up your keyboard, say a couple of letters, and then I should be able to see it here. Thank you, Mr. Durai. I was expecting that. Mr. Mahendra and Strujan, no response. I can't get you moving, I guess, today. You guys are really stiff. Okay, fine. Since majority are on the no side, I'm going to say this. About a few years back, Oracle was owning, I'm sorry, Sun was owning MySQL, that is the SQL database. It was open source, and Oracle bought Sun Microsystems. So some developers were not happy with what happened, and they went ahead and created something called MariaDB. So both of them run the same database engine. this one and this guy are almost similar, but there are minor differences between these two guys, but that is not a difference that you will come across in a very common everyday scenarios. So what you need to know is these are almost similar. This is owned by Oracle. This is owned by open source guys. And since Amazon doesn't like to play with these kind of things, what Amazon did is they took these two things, that is MySQL and MariaDB, and created something called Amazon Aurora. So in other words, Amazon Aurora is compatible with MySQL and MariaDB, but it has some enhancements on top of it. So let us say MySQL can support about 30 terabytes. I don't know, but there is a limit on how much you can store in MySQL in RDS. Amazon Aurora has put that limit higher. Let us put just a simple number as 50 terabytes. So that is the kind of improvements Amazon has done on top of MySQL. There are certain other enhancements Amazon has done on top of MySQL. So you will see that when you start using Aurora DB, and then there was a conference for Amazon a couple of days back. I keep repeating it. The reason is I learned a few things there, and one of those things is Amazon Aurora is the fastest growing service in AWS in their history. I mean, let me repeat that they are there in the market for almost 11 years now in the cloud market, and S3 was their fastest growing service once upon a time. But they recently announced it that Amazon Aurora has been growing even faster than any of their services in the market. So what it means is a lot of people are finding value in running an database in Amazon Aurora rather than using a basic MySQL instance. It might be interesting for you to know that. Probably it will not help you to clear an interview or an exam, but whenever a client asks you, should I use a MySQL instance or an Aurora instance, depending upon the use case, you can recommend the right options for your client. That's the reason of me sharing that information for you. So moving forward, this slide we have spent a lot of time. This also I think I spent some time here as well. Let me close this. Okay. So instance database and security, as I said, database instances are the building blocks. When this line says database instances, it refers to the underlying EC2 instances. Each database runs as an instance in your VPC. You can go to your console dashboard and see that information saying one IP is being used by your RDS instances, and you can have multiple databases in each of those instances. Very typical of your on-premise setup. If you have, let us say, an IBM server running or an Intel server running for database purposes, and you have installed MySQL or Oracle, you can have multiple databases installed. Let us say one database is specifically for my employees. I will have my employee name, age, date of birth, what department, what is their employee ID. Then I will have one more database for payroll. I will have each employee ID as my primary key and have their basic salary and their variable pay and their fixed other components, all those things. Then I will have one more database for my employee to say what kind of building access they need, whether they need access to building A, whether they need access to building B, and what level of access to each of those buildings. So my employee ID or some kind of a parameter for my employee will be the primary key which connects all these databases, but I will have multiple databases for each of those use cases. So that is what it means. I will have one database instance and I will have multiple databases created inside them. And they are all isolated inside your VPC. That is how your security is brought into the picture. And you also can, I have not shown it here in the image. I didn't want to add too much details, but you should definitely use a security group for your database instances. Whenever somebody asks you how do you secure the database, you start by saying I will put it in a very custom defined VPC, and you also tell them that you will put it in inside a security group, and ensure that access is coming from instances I trust. For example, my database instances should be connected only from my application instances, not from the external world. You can do that. You can connect two security groups and say the incoming traffic has to be from only from this security group. So you can have a web security group. To think of a three-tier architecture. That is, the first layer is web servers, the second layer is application servers, and the third layer is your database servers. So only your application is going to talk to your database. So you ensure that your application is in a separate security group and database is in a separate security group, and you configure incoming and outgoing rules using that. Then you have NACLs. If you remember, network access control list is there, which are subnet level access controls. You can use that also to tighten your security. That would be sometimes a overkill when you're using proper security groups itself. But sometimes, if your VPC is having a lot of crowd and only subnets are there to define each of them, and only one security group is to define all of them, then you go to network ACLs and define your security based on subnets. And it's a good practice to have a separate subnet for your database layer. I'm just sharing some best practices. If you didn't follow it, talk to me later. I don't want you to ignore this part. I want you to understand this part. Just imagine security VPCs, security groups, and network ACLs are there to enhance the security for your databases. I keep reiterating security part because whenever people talk about cloud, whenever people talk about cloud security, they say, how can I put my database on the cloud? All my data will be on a third party sharing an instance with another customer. How do I ensure it? Then in those kind of discussions, these answers will really help you to get the conversation in a positive direction. Otherwise, you will be cornered saying, I cannot have my instance sharing my data with another client. I cannot ensure security. So having said these three things, VPC, security group, and network ACLs, you can also say that RDS enables or allows you to encrypt the data by using a checkbox. Yes, exactly. EBS volumes are remembered as a checkbox encryption is possible. Here also, you can encrypt your databases by using a checkbox or a drop-down option. As simple as that. That's the point. So you can have encryption at data at rest encryption, and you can also use SSL certificates, and you also can use client-side encryption, and all those things are also possible to enhance your security. So moving forward, what else do we have here? Okay, some of those items that we just now discussed is coming up on the screen. If you have any questions, voice yourself right now and we can move forward if you are all happy with that. The last line is what I said. Using each database engine gives its own features to control the security of your database. For example, how many user IDs you create on your database itself matters, right? So you can use your database engines to security features. Here you won't have user ID, you will have an IAM role mostly. You will never have access to your database directly. You don't have a database console or anything. You only have a client-side interface, and that is MySQL client or something on a third-party machine you will install, and not third-party on a second instance, probably an EC2 instance or somewhere elsewhere, and connect your database and interact with it. You don't get a console level access for your RDS instances. So that is for security. Let us move forward. And backups, automatic backups and manual backups. So Amazon helps you to automate your backups. As I said, it's typical of your cron job that you see in your on-premise instances, or for Windows people, they might be familiar with the scheduled jobs. Something very similar is available on the console. You go and configure what time you want your backup to happen and how long you want to retain it, and all those kind of things are possible. And you can also trigger a manual snapshot also from the console. You just go and select your database and right click, just like think of EBS volumes, and you go and click on your create snapshot. It just creates a snapshot. And as always, most of the data Amazon creates or you create, it gets stored in S3, And you should remember that whenever you put something in S3, it is durable and it is highly available. Durability of 11 nines and availability of 4 nines. So in the manual backup, you can see that it persists until the user deletes them. That means that the manual snapshots reside in your S3 account, S3 usage, and it will be available until you delete them. And just a point here, if you create a snapshot, don't try to go and search it in your S3 console. You will not be able to find it there. That bucket or whatever mechanism Amazon uses to store them is not visible to you on your S3 console. You have to look at your snapshots in your RDS console only. Sometimes people ask this question, can I directly interact with them through S3 commands or S3 bucket options? That is not possible to my knowledge. You have to interact with them using your RDS console only. So moving forward, this is another interesting aspect of it. Before explaining what is on the slide, I will just give you a scenario which will make it easy to understand. Probably I don't have to explain it. Let us say your development team is in, let us say, east coast of America. They have created this database, fantastic database, fine-tuned it, optimized it, and made it ready for go to production. And your manager comes up and says the production instances are going to run in East Asia or somewhere in South America. So you need to copy all your configurations of your database and move it somewhere else, including the data. So you can take a EBS snapshot, do a replication across the region, or you can use the database replication itself as a possibility. That is what is shown here. You configure your database, store some data, you can create a copy of the database snapshot to a different region and start using it there. You can use the same mechanism for a database disaster recovery also, solution also. Think of this scenario. You have configured a cron job. Every day it runs at, let us say, midnight, and you have written enough scripts on your target destination saying, well, as soon as I have a successful snapshot backup from region A, test it by booting up a small T2 instance and make some read-write queries and say that everything is fine. And you also do a health check with region A. If my region A is not available, make this instance as a, probably when you're doing, you will do a T2 micro testing or T2 medium testing. So when your health check on region A fails, you will upgrade this instance to, say, for example, C4 large and connect it to your database snapshots and reroute your traffic from Route 53 to this instance. And you can do all these things with the help of health checks written in CloudWatch or Lambda, whichever is familiar with you. We will look at CloudWatch in the coming classes. So you will configure health checks. The health check can be as simple as ping my EC2 application or try to query this page. www.google.com should be accessible. If it is not accessible, point the traffic to another server. So that is how you create a simple DR recovery solution in AWS. And also, of course, there are compliance requirements. People sometimes ask you to move data across the continents for compliance regions, or it can be also for typically for migration or testing a new service. Somebody will say, I'm going to start a new service. I want to run some reports. Can you copy the data to my system so that I can run some reports locally? So in those cases, you will copy the data, set up a small instance for them, and give access to those guys to run some reports. So this is how cross-region replication or cross-region snapshotting helps for you in real-world scenarios. Okay, this is a slide I was talking about, which is off the scale. I don't understand why. I'll have to fix it. But anyway, content which I believe is more or less visible is what we need to focus on: DB parameter groups and DB option groups. Let me talk about DB parameter groups first. Every database has a certain amount of attributes which is configurable and which enhances the performance of that database. One very simple and common example that is easy to explain is time zones. you need to know what time zone or what time parameter your database is going to use. By default, Amazon configures everything as a UTC time zone. Say, for example, India is 5.5 hours ahead of UTC, and America is somewhere behind UTC time. So if you don't want to use an UTC time, you will need to configure your database parameter for the time zones to an appropriate time zone that reflects your customer needs. That is a very simple example that I can give. There are a couple of other examples which are very common that you will have to use in your everyday scenarios. For example, you will change the locale setting. Anybody not familiar with the locales, think of whenever you install Windows or Linux, it will ask you to choose what is the language that you want to run that operating system on, whether it is Indian English, US English, UK English, or Spanish, or Italian. These are all the locale settings or regional settings that you want to use. This is really important, guys. The reason is English by default doesn't have any special characters on top of it. Um, Say, for example, Hindi, or best example, easier example would be Spanish or Italian. Their alphabets have some tildes or stress marks on their alphabets. So some databases breaks when you're trying to input those kind of characters when your engine is not set for accepting those values, because it doesn't understand what to do with those characters. So you need to fine tune your database with those locale settings in case if you're going to ingesting those kind of parameters, or you need to do some cleaning before ingesting those kind of parameters. The other example that I can think of is numerical values. Say, for example, in India, we use a different kind of comma system, like it is unit, tens, hundreds, thousands, 10,000s, lakh, million, I mean, not million, lakhs, crores, it goes on. Whereas for American system, it is, they go the three digits, that is unit, tens, thousands, and then they go to millions and then billions. So if you want your numeric system in your database to reflect which region you are in, what a decimal point you want to use, those kind of parameters that you can choose it here. So those are the very common and easy things to understand, but keep it in mind that there are more complicated parameters available, and you can combine two or three parameters to create an interesting combination of to apply on a particular column, or yeah, particular column on how we want. In other words, how you want to store the data in your database is what these parameter groups are. So that is what it defines here. Say, for example, you want a dollar symbol in front of your numbers, or you want a pound symbol or an Indian rupee symbol. What is the data? What is the value of the rupees that you want to store? Those kind of things helps you to configure your parameter groups. Similarly, option groups currently available for four of the database instances that is available. These option groups are nothing but makes your database management easier by upgrading them or patching them, or what can I say, snapshot, not snapshotting. I forgot the other one. If I recollect, I'll let you know. Option groups, in other words, is mainly for managing your database only. For configuring and fine tuning, you always use your parameter groups. So those are the two things. The image on the right hand side you see here, right? It says an engine. That means that this instance is running an MySQL, that is a Microsoft SQL Server, and then it for some reason it is the other two items are blocked out because they don't want to show the publicly that information. And also you have this option groups and parameter groups set up. Say, for example, if you change a parameter group, this is very important. Sometimes I have seen this question in interviews, very rarely in exam. By default, Amazon gives you a parameter group, and assume that you have started an instance and it is running for 10-15 days, and your customer comes up and says, can you please change this parameter value for me? Okay, since everything is easy in AWS, you go ahead and change the parameter group. Does it take it into effect? No. Unless you reboot your database instance, the parameter groups are not taken into effect. The reason is that most of these parameter groups are read into the kernel, and a database is constantly using it, and it will not allow to be modified when it is running it. So most of the parameter groups will require reboot to come into effect, or in other words, a recycle of your database, or in other words, a downtime is required. So that is quite often disruptive activity. So if somebody comes up and says, can you change it quickly? You tell them, I can change it quickly, but it won't come into effect until you reboot it. So that is why I highlighted this bottom on the right cycle. You see that there is a pending reboot. That means there is something has changed from the last time the server started running, and there is a new parameter group available and won't take into effect until you go ahead and reboot it. The very simplest of applications looks like this. You will have a load balancer in the front distributing traffic to your application servers. It can be an auto scaling group, or it can be only a couple of servers that you manually configured and attached it to your load balancer. And those application servers will have a JDBC connector or a MySQL client. To talk to your database, you will need some kind of a connector, usually from your application. So when I say JDBC, it is nothing complicated. It is a Java database connector. That is what JDBC is, Java database connector. You can have a JDBC connector for most of the common databases in the world, or if there is even there, it is not, one is not there, people quite often write it and open source it. So most of the JDBC connectors must be available for you to copy the example code and use it. That is, in other words, those libraries will be available. You can start using them quite easily. And finally, you have a master database instance. I'm going to just move back a little bit. Oh, I'm not able to find it here. Okay, this slide will do. I'll pause for a moment to see that you can see the screen. Can you guys see it? I'm not able to see the attendees view.
I can see the screen.
Okay, great. What I wanted to show here is that usually when you're configuring a database, you will configure a master instance and also a read replica instance. There are multiple reasons for that. One is the master instance will allow you for doing a read-write access, whereas when I say read replica, as the name says, it will allow you to only do a read operation on top of it. Why would I do that? The reason is I don't want to have two masters running all the time. I will have only one master running, and I will have all my queries routed through my master. The benefit is that if I have two masters, read and write operations happening on both the sides, I need to constantly try to sync both of them so the data is consistent. Think of two people trying to access the same file and modifying at the same time. Somebody has to keep consistency, right? If anybody has worked on Google Docs or Google Worksheets, something like that, cloud-based Excel sheets or cloud-based documents, you will know this problem. Two or three people trying to edit it, the same line or same record, always creates confusion. So you need to have some kind of consistency to be maintained across all the database instances. So that is why you create a master instance, and then you create a lot of read replica instances. This way, all your read write happens through one instance, and then you can replicate this data to a read replica instance. Now you can ask me, why is that the case? I need a read replica in that phase if I'm routing all my traffic to a master instance. The reason is if your queries are going to be only for a request for information, they are not going to modify any information in your database, you can directly route it to your read replica instance. For example, anybody written an application will know that some queries are, say for example, Amazon, if you're typing, I want to know what is the latest pair of shoes, Puma shoes, size 9, less than this price. That kind of a query is not going to modify any data. So I am going to route it to my read replica instance only. When you are uploading a photo, say for example, or uploading a file to your Dropbox or any other storage service, that means that you are going to make an entry into your database. You're creating an additional entry into your database. In that case, that traffic will be routed to your master database. So depending upon the type of query, application developers or users will route their traffic to your master and read replicas. You don't have to configure this routing of traffic and all. I'm just saying all that to understand where a master is getting useful and where a read replica is getting useful. Another use case for a read replica is business users, or think of people in the coat and suit who sit in the meeting rooms and bark at you when something goes wrong. Those guys will run some reports or require some reports. That reports are mostly going to be reading from a lot of tables and creating a collation. For example, think of Coca-Cola, or not Coca-Cola, let us take Airtel as an example. Airtel has a lot of these small kiosks or vendors in the street corners selling prepaid cards and postpaid cards and all those kind of things. And say for your manager comes up and says, I want to know all the sales that has happened in the last 1 week for the new plan we launched yesterday, something like that. He gives you query, so you go and run that query in your read replica only. You don't have to run it on your master database, so that you don't block any IO activity on your master. So all the load of retrieving all this data from multiple tables, all the collation, joins and unions will happen on your read replica database, so that you can have your master data free for your customers to write to it. That is, IO will be free there, it will not be blocked there. Most of this activity you will not be doing it, that is routing this traffic, ensuring that reports are running on the read replica. You will not be doing that. Application developers will be most probably taking care of that problem. Your responsibility will be to create an architecture which has one master or multiple masters and even more multiple read replicas. So that is what I wanted to show here in read replicas. Where were we? Here. Okay, in the simplest of architectures, I'm coming back to the same slide where it says simple application architecture. You have load balancer, you have an application server, and you also have a master database instance. If you want to complicate it a little bit more, if you want to have a more complex application, um, okay, I'll come back to the in between slides. A more complex application, a durable, resilient architecture will look something similar to this. How do I achieve this? We will just go back a couple of slides and look at those topics, and then we will understand how to do this. So far, if you remember, I did not tell you how to have high availability and resilience. That is what we are going to look at now. You can have multi-AZ deployments for your RDS also. You don't have to do any specialized operation for this, or and there is a drop down for you in Amazon console. You just choose that I want to deploy my RDS instances across AZs, in other words, across data centers. If you want to drive that point, if you want to have availability on two different data centers, then you choose this option, and Amazon will take care of the replication between these two instances automatically. In other words, you will have a kind of a standby master copy in another AZ, always on standby. So the image on the right hand side, that is what it shows. There is an master database instance at the bottom, and all the data is coming in here, and Amazon will ensure these two databases are in sync at all time using the low latency connection that Amazon has between availability zones. So for some reason this guy goes offline, Amazon will start routing all your traffic here. Automatically this guy will be promoted to a master copy, and you can start read writing to that instance automatically. You don't have to do anything. That is what this point says here. Failover automatically occurs to standby in case of master's database failure. In other words, you have two databases running in master configuration, and the replication happens automatically, and failover also happens automatically. Only one catch is you cannot start using both of them at the same time. Say for example, before anything wrong happens, let me just draw once again. Say you have this database also, and the replication happens here. Some cheeky people can think of, why can't I write directly to this guy also? Because it is standing there idle. Why can't I write to it? This is not possible. Amazon doesn't allow you to do this. All your traffic will have to go through this guy, and your replication has to go from this guy to this guy only. Only when something goes wrong with this database, the standby will come online. Is that clear? This is how multi-AZ deployments work and how multi-AZ deployment ensures your high availability. Again, silence. Guys, if you're silent, you know what, it is easy for me. I'll just move on to the next slide, assuming that everything is clear. If you're not clear, I would like you to raise your voice and tell me that something is wrong, I don't follow. Please repeat it. Okay, we just now saw this. You have a load balancer, you have an auto scaling or some kind of a group of application servers, and you have a master copy which is in a multi-AZ configuration, and you have a slave copy also. You can have a read replica also. It depends upon whether your application needs a read replica or not. It is absolutely for user discretion, I can say. And your snapshots go to S3 buckets. I should not say S3 buckets, I should rather say S3, because you don't have access to S3 itself directly when you create a snapshot. I'm not going to start on Dynamo GB. I don't even have slides on that. But anyway, what I want to do is I want to close off today on time, or at least once. I don't want to drag on every day. What is this? RDS. Where did I come up this slide? Okay, let us look at this one quickly. If you can read this, I don't know how I ended up here. 1 second, guys. Right, yes, you really need to see this. Yes. Best practices for RDS, the imagery and the text is not formatted properly, but the content is still relevant. You should monitor your memory, you should monitor your CPU and storage usage, and always use multi-AZ deployments for your production servers. If you are going to test them, if you are going to do a development, you don't need multi-AZ, but for production, always recommend your customers to go for multi-AZ. You should ask me, what is the catch here? Cost is the catch here. If you do multi-AZ, Amazon charges a different cost, and if you do a non-multi-AZ, there is a little lesser cost. And you should remember this if you're going to test it, if you're going to do testing in your own account, you don't need multi-AZ. You just configure it a single instance and start using it. Don't try multi-AZ when you're trying to learn RDS databases. And you should enable automated backups, and you should also set your backup window. Just like conventional environments, Amazon allows you to configure what is your backup window, probably in the night time. If you are an US based client, you will configure something in India or daytime or something like that. Least period of usage, that is what Amazon asks you to choose. And you can also choose your upgrade cycles and all those things. And test your database failure also. Each account has its own mechanism of testing things. Come up with your own testing policies and test it whenever you want to ensure that your high availability is working fine. And yeah, if your application is caching, you need to ensure that the caching is refreshed every 30 seconds. The reason is, if a failover happens and your application is still pointing to a RDS instance on the primary copy, there will be failed transactions. That would be the right thing to say. Yeah. So if your application is caching your DNS pointers, set a TTL saying 30 seconds so that any failure will be picked up immediately and your application will start routing traffic to your correct master copy of your instance. So today I am not showing any demo. I want to close off on time today at least. So I'm going to close off here for the session, and tomorrow we will see a hands-on demo of setting up a RDS instance, configuring a couple of parameters, and taking snapshots, restoring from snapshots, and all those things. Okay, I'm sorry, it is going to be on Monday. Saturday, Sundays, I usually don't do this. And it is going to be on Monday. We are going to see RDS hands-on demos. Okay, I'm just waiting for you guys to have feedback. No, that should not be working.